Alright, another conic section, the hyperbola, which is a fun one. You can talk about a vertical hyperbola or a horizontal hyperbola. Okay? And each case you have a center. So I'll just mark a center point, and then from your center point you have vertices. The vertices for a vertical hyperbola are up and down. The vertices for a horizontal hyperbola are left and right, and so the blue points are called vertices. Each of them is a vertex. When you have two, they're called vertices. Then you also have foci. Unlike an ellipse, the foci are further away from your center. They're not inside. They're further away from your center than the vertices. Okay? They're not inside the vertices. And you'll see why this is true in a moment. Now we need the asymptotes. This is a key part of graphing hyperbolas. Asymptotes in this case are lines. And what they are, they're basically like the boundaries for the curve, for the hyperbolic curve. And so we will approach these lines, but we won't actually touch them. So to get the asymptotes, we've got our vertical distances here. Now we need the perpendicular distances here. So we'll talk about later how to find these, but let's say that they're right here and right here. And then on the horizontal hyperbola we need the vertical distances. So let's say here and here. So what we're going to do is we're going to use the blue and the red points to graph the lines. And the way to do that is to use you're going to basically use a rise and a run. You're going to go up to the blue here and over to the right. Rise and run. And now you've got your center. Your asymptotes always go through your center, and they go through basically where these 2 points meet, the vertices and this red point, which doesn't necessarily have a name. So one asymptote connects your center to this point. The other asymptote connects your center. We're going to go up, and now we're going to go over to this other point. Okay, so now you've got two asymptotes going through the center and basically like these corners. Okay? And now the graph, let's go ahead and do the asymptotes for the horizontal as well. Now we're going to use the red and the blue points again. The foci don't affect your asymptotes, by the way, directly anyhow. So we're going to go up to the red and over to the blue to get an asymptote here. And we're going to go up to the red and over to this blue to get the other asymptote. Dashed lines are a typical way to draw asymptotes because they're not really part of your graph. You're simply using them as some sort of boundary. So now the vertices, your curves always go through your vertices, by the way, whether you're talking about a parabola, ellipse, or hyperbola. So we're going to start at this vertex, and then I have to wrap around my focus. Just like a parabola wraps around its focus, just like an ellipse wraps around its focus, I need to wrap around here. But I also have to get close to the red lines. So I'm going to immediately come out wide and begin approaching my asymptotes. Okay, and see how this curve wraps around this focus. I'll do the same thing down here, wrap around the focus and approach the asymptotes. Wrap around this focus and approach these asymptotes. Wrap around this focus and approach these asymptotes. And you can see, sorry, I didn't mean to touch the asymptote there. You can see why this is a vertical hyperbola now, because it opens up and down, horizontals open left and right. Now we need to talk about the relationship between the distances in this graph. So let me clean this up a bit. There are three distances we're concerned with here. We're concerned with this blue distance, the distance to a vertex, which we'll call V. We're concerned with the distance from the center to a focus, which we'll call F. And we're also concerned with the distance from the center to this other point, which gives us the asymptotes, which we'll call M. What's the relationship between these three? Well, they satisfy the Pythagorean theorem. And in the Pythagorean theorem, the biggest side is like the hypotenuse, and in that case, the biggest number out of these three is f. Right? That's the biggest number out of the three. So, the relationship between these three numbers is the big number squared equals the sum of the two smaller numbers squared. And so that's the relationship where you might have to find f.